Today we have a NeoGeo classic 80s, 90s arcade machine. This thing has been given to us by a customer who is asking us to repair it, today we're going to see exactly what's wrong with it. First problem is the screen is getting blurry around the edges. It's not uncommon on these old arcade machines. These tubes are usually run 24/7. They've had a long service life and they're usually B grade tubes to start with. They're not A grade, which is what you'd commonly find in a television tube that you'd find in your household. We will test it and it will probably be the tube itself, but with any luck it's just the chassis. The other things that we'll be looking at is replacing the buttons and just doing a general check to see if there's any other issues with the machine. Now, there is a game PCB in here already called Snow Bros. We'll give that a quick turn on, see what it's like. You've got your power supply, your service test, coin credit PCB's missing. That doesn't matter. Yeah, let's turn it on, see what happens. Okay, we've got noise. Well, the first thing you can see is that the screen is very dull.
Just lost batteries in that. Say that again.
So the first thing you can see here is that the screen is very dull. There's not a lot of brightness in it. It's not crisp. It's not vibrant. It looks very tired. The second thing you'll see, if you're familiar with this game, is that that's not what it's supposed to look like. So we're probably looking at a game PCB fault, as well as a problem with the tube or the chassis for the monitor. By the looks of it, everything else is at least in serviceable condition. We'll do the general run around, make sure that the wiring's okay, make sure that the voltages are set correctly, and that there's nothing in the back, cockroaches, rats, stuff like that. So what we'll do is we'll turn this off, we'll discharge the tube, and we'll test the tube first. My suspicion is it's going to be the tube. NeoGeo cabinets have a history. The ones that were built in Australia, they used a brand that was not very reliable. And quite often you'll see NeoGeo cabinets with tubes that are faded. They are usually the fault. What we're going to discharge with, there's a couple of different methods. The correct method is to use a high voltage probe. You connect this to your earth strap on the tube, and you put this under the anode cap, and there's a massive resistor in there which limits the flow or discharge from the tube and prevents any damage to your chassis or to yourself. You can also plug it in to your multimeter. I've got the multimeter here. You can also plug it into that, and you can actually measure the voltage level so that you know when it's at a safe level to just grab the anode. When I was very young and I was just getting into arcade machines, electronics and hobbies, I didn't have a high voltage probe. I didn't have eBay to buy it off, and there wasn't, the local Dick Smiths didn't have this type of stuff. And so what I did was a bit of research, a bit of information from a couple of people I knew at the time, and I made this. Basically it's just a clip, alligator clip, and a screwdriver. A bit of wire, basically connecting it to that, and just make sure it's insulated basically. Again, connect this to your earthing strap, and this here is what you would put underneath the anode cap. The problem with this is that it doesn't limit the current. It doesn't limit anything, so you get a big crack, full discharge. That's okay most of the time, but it's theoretically possible to damage things, especially if you don't attach this to the earth strap or there's something else in circuit. that you've attached this to. I won't use this today. I'll use the correct tools, and what we'll do then is I have this. This is a Sencor CR7000 tube rejuvenator, as well as a tester. I purchased this and it is the best tool that I can think of for when it comes to dealing with old arcade tubes. This thing has shown me what's faulty a lot quicker, and it's also repaired a few tubes and given them a little bit more life when they can. We'll be using this thing as well to test the tube. We'll just turn this thing off. Now the arcade PCB that is in here it's small, it's faulty. Most of the time it's just one problem, but over time these things can develop multiple faults. Corrosion can eat into things. EEPROMs, especially ones with these things off and the windows are exposed to UV light, can get wiped. They tend to just fail over time sometimes, just for the fun of it. This particular motherboard and the fault that we saw on the screen with the flickering is most likely a RAM issue, and most likely it's going to be a frame buffer, and usually the frame buffers do one frame, and then the other buffer, there's two sets, and one will do one frame, one will do the other. On this particular PCB, you've got your CPU RAM, program ROMs, and sound CPUs, sound ROMs, a little bit of associated circuitry, clocks. The custom IC here is probably most likely going to be responsible for all the graphics, and usually you'll find off this the mask ROMs, which usually hold the permanent game data and game graphics. These ones here usually hold the program data, which they can fix bugs and stuff like that and reprogram them over time. The RAM attached to this is usually close by, and in this particular case it's this lot here. To fix this PCB, it depends on whether the customer wants us to do it or not, but to fix it, it is most likely going to involve testing these. Usually you just test the outputs with a multimeter or not a multimeter, a digital probe, or a
Logic
probe, or a oscilloscope. Measure the outputs. Usually you'll see dead outputs on one of the address lines or the data lines or something like that, and usually that tells you what's wrong, and then you just desolder it, plonk a new one in, and the game board's fixed. But we won't deal with that right now. We'll take that out so that we don't do any more permanent damage to the machine or the game board, just in case. Okay. Most arcade cabinets have access at the rear. This one does. So that's good. Okay, what we have here, you got to remember this was just on, so the tube has still probably got a really high charge in it, and it's not a good idea to just touch any of this type of components without knowing what you're doing. So what we have here is the neck board, the chassis, and up here attached to this cable here is the anode. It's a big suction cap, and unfortunately it's a little bit hard to get to, but that's okay. This particular tube is an LG A59 KYL220X. So we'll look that up in the manual for the Sencor, so we can plug it in, and away we go. So what we'll do is we'll discharge this now. voltage is set to the highest on here, set to DC. We'll just put that there. Your ground strap. Some people attach the ground strap to the chassis, but I always attach it to the actual strap. The thing you got to remember about the strap though is that if the strap is not connected to the neck board like it should be, it's not going to work too well, and you'll end up discharging the monitor through yourself or something else. So the first thing you need to do is make sure that it's got the strap around it. It's a metal braid strap, which it does. Now the strap is connected to the neck board just here. So as long as it's actually connected, usually you'll have a complete circuit that you can discharge. So we'll attach the strap. I like to attach it to the closest point to the wire, so that if there's any problems with the wire or any breakages that you can't see on these old machines, you limit your problems. Now, unfortunately, we can't remove this panel here unless we get some tools and pull it out from the side. So you can't actually see the anode cap behind here, but I'm going to put this up through the anode cap, and we should see some numbers here representing the voltage. Now it is divided. It is divided by the resistor in here, so it will bleed it slowly. Okay. So as you can see, you're getting a number there. Okay, we'll lower the range down. So we're in the 200 volt range. Okay, just slipped out for a second. Now I have bled a reasonable amount of the current out, but I don't think it's completely out just yet. As you can see, it's going down slowly. Once the bulk of the charge inside the tube is out, it is generally safe to remove it. The problem I find with these things is that when the voltage inside the tube just gets a little bit low, it takes a little bit of time to discharge what's left, and that's when I like to use my other tool. This thing will take what's left out of the tube, and we can remove it. The other thing you got to remember about most tubes is that they'll build up some of that charge again, so don't just think that after you're discharged it's safe. You'll probably find after half an hour, you'll get a little bit of a tickle again from a bit of residual voltage that's rebuilt back up in. You just discharge it again, and it's usually fine. The reason we're discharging the tube as well is so that it doesn't accidentally damage my test equipment. We don't actually need to remove it for this particular test. All we need to do is remove the neck board itself. That crack noise, if you heard it, was what's left of the charge. Okay. Now that it's at a safe level, before you remove these, the neck, if you're not familiar with the neck, there's a little nipple under here where they seal it off, make them vacuum all the air out. If you crack it or you hear a little gas leaking noise or something like that, your tube's had it. You've broken your tube. So you've got to be really careful at this stage. Pull it off straight. Don't wiggle it violently or anything like that. I have seen some of these plastic protectors that are around the pins and the actual glass nipple break or fall off because of age. They're just brittle, and if you're not careful when you're wiggling them off, you end up snapping the nipple and your tube's had it. So we'll just pull this one off nice and straight, which is good. That one came off nice and clean. Okay. set our power. Now the first thing we have to do is look up in the manual the tube type. All tubes have different pin arrangements and pin counts. They're not all the same, so you've got to get this. Once you've got that, you can then pick the right adapter. If you're really unlucky, you'll have to manually wire it up with one of these things. But today I don't think we'll need to do that. First thing we'll do is look up the tube, which is an A59XY. So we've got A59. Now, if you're lucky, the tube is in the book. If you're unlucky, the tube is in the book but in a different spot. It's not what you call alphabetical. There's some stuff that's alphabetical and then they go backwards, then they go forwards and all sorts of stuff. So A59K, KY, I think I said XY before, so that might not help me. Okay, A59KY L220X. Okay, so we've got an A59KY L220X, which is written there. We need socket type 1, and this information here tells us what to run the test equipment at for the different video types and voltages and stuff like that. Okay, so we need to get socket 1. Socket 1. Socket 1 will fit on there and we'll attach it to the machine with this. Nice and safe. Okay. Now I got this unit from direct from the US, so it's actually still wired for 110 volts. I use an isolation transformer for safety, as well as obviously the step down of the voltage, so that we can use this. Okay. On our equipment here, we have the test guns. We can either do red, green or blue or simultaneous. We have the CRT type, power switch, filament volts, the bias, your adjustment for the filament volts, and we've got various controls here for when we're doing our test. So what I'll do first is I'll switch everything to their base levels, and then we'll have a look at the manual again. Now the A59XYL220X is socket type 1, video 1, which that's on there, 100 volts bias, so we switch that up to 100 volts bias, which is at the top there, and the filament volts, which is 6.3 volts. That's pretty much standard on most tubes, but not all tubes. So 6.3 volts. You'll notice that on this particular test equipment, we have 3 ranges, 0 to 4 volts, 4 to 8, and 8 to 16. So we'll switch it there, and we're ready to go. Now we'll switch the power on. Now the first thing you'll notice that comes up is your filament volts. So we'll just adjust that to 6.3. Okay, just down a tad. Okay, now what that's doing right now is it's applying voltage to the tube for the filaments so that we can run some of our tests. Okay, so the first test we've got here is the filament volts. The first thing you want to check for is a G1 short. which is the different grids, you've got a heater cathode, then you've got your other tests up here which test the gun's life and stuff like that. So we'll switch it to that. Now this is in the green, which means that there's no G1 short. If these drop down or go into the red, that means there's a short in the tube, and you'll get things like flaring or sparking or problems with the tube of that nature. So that's good. We don't need to adjust that. The next is the heater cathode short. If you have a heater cathode short, I'm pretty sure that your tube is shot and you can't fix it. As we can see again, all good. So far so good. Now we've got the cutoff and tracking. Now what we need to do first is we need to adjust these to the cutoff. Now, I'll just adjust these up. If there's problems with the tube, this will show up here. So as you can see, I've got that on maximum and we're not getting that in the range. Same with the, so red, green and blue, I'm not getting any response from the cutoff, from the cutoff test and low tracking, which means that I'm pretty sure, don't quote me on this, but I'm pretty sure that with your low tracking, it's to do with the darker colors, the contrast of the tube, and the high tracking is to do with brightness or something like that. Don't quote me on it. I've read the manual a couple of times, but sometimes it takes more than a couple of times. As we can see, that's failed that test, so we've got emissions and high tracking. So as you can see, emissions and high tracking, we've got our green gun at maximum is probably the best out of all of them, but as you can see, all three have pretty much had it. So this tube is pretty much dead. It's got no life in it.